So the second application is an automotive casting. So we'll just jump into the scanners. This specific one was done with an arm, but you could do it with any of these types of devices here. More of like a little larger part, but you can scan with an arm type device like these. And you'll see here, this is a steering knuckle from suspension on a part here. In this example, we scan this part, and you'll see the strategy that we took here in a second. I'll walk through the history. This is a shorter history tree than the last one. But then what's really interesting is after we created that casting plug, you'll see that we were able to print this in wax, create a wax pattern, and then you can cast that wax pattern and create the casting one-off. And I've done this personally before where I've modeled a legacy part one-off and printed it in wax so a casting company can create the casting and then melt the wax out of it. So let's go ahead and switch over to Design X, and you'll see here is the scan. Beautiful scan from an arm. And with this one, what's special about it is if you roll all the way back, you'll see that we have the knuckle scan and a region group, and you'll see we have a copied scan. So I'll go roll back just behind that. And what's different about this workflow that's nice is you'll notice this part has a lot of organic shapes. And as I talked about in the last example, you have all the tools to surface model this, but there are lots of times where you have a known working part that's a cast model that's been made that way for many years. And you might want to take that organic shape of this and then cut new hole sizes in this, because sometimes there's slightly different modifications to the suspension, or you just need to remove all of the holes from this and then auto surface it and then model in all of the holes later. So the way this workflow goes is we'll go ahead and turn on the other mesh. What we did is we took that original mesh and we modified it in a few different ways. So you'll notice some of the ways here. Went ahead and in some of these areas deleted the holes. And again, I can toggle this on and off. So remove some of these areas from the mesh. Same thing here. You'll see that we just remove all of this and do a mesh hole fill. And even on this back side, we did an extrude boundary. So deleted that face, extrude boundary, and added material there. So that way we have something to cut away from. So we often talk a lot about Design X and all of the CAD tools that it has. But we also have a lot of tools here to edit a mesh, right? So you see here, you could come in and you could take a tool like this right here, and I didn't remove that inner area, so we'll just do that real quick first. Trying to get cute here, but I'll go ahead and just paint that. Just going real quick here. There we go. Hit delete. Then, so the issue is if it's a wormhole where it goes to the other side of the part, and I use this tool, it will not be able to select everything within the bounded area. So that's what it was doing. So often mistakes can be a great teaching moment to show you what I did without thinking here. But I can now say that I would like to delete that area. We're going to select it, then hit delete. I'm just showing you how these tools work. What they did is they went around the part and took that area and then come over to the hole fill tool. And you can say, I want to fill with a curvature based fill, select that boundary and remove that. So plugging in a mesh, changing the mesh, sometimes you don't want to reverse engineer exactly what's there. You want to modify that mesh and then work with the modified mesh and reverse engineer it. And then you also have some tools like the Smart Brush tool is really neat too, where I can come in if there's some witness lines of little creases and things like that, I can smooth those out, make modifications to it, hit OK, and then take that. So we went around the mesh and removed all those areas and created this example right over here. So we'll just turn that back on and then hide that one. So this, we went ahead and auto surfaced. So roll forward. And the auto surface just goes around and wraps surfaces around the entire mesh. So turn the solids on. That way, I don't have to model all of the organic shapes. And with castings, this happens all the time with this industry because, again, it's a legacy part. It's over-designed already, so I'm not worried about the parts engineering aspects of the casting itself. I know this part works. It's been designed. It's worked forever. I'm just going to reproduce the same one with some modifications. So now, after you create that, you can now cut away, kind of like what we did in the last one. We'll just take it a few steps forward here. So we'll go ahead and bore out that middle area. We'll come over and fit a surface feature to that area there. We'll cut it away, and that's exactly why we added material by extending the boundary there and then doing a flat hole fill there. So see that? It's coming together now. So you can just go around to each of the mating points of this part and add the features, the cutting away, because this is kind of simulating the manufacturing technique of these parts anyway. With the casting, you'll create the casting and then they come back with mills and lathes depending on the part, right? And then they will mill away and create machine surfaces from there. So it's a really neat workflow to be able to come in and you're basically virtually doing the same thing that you would do in real life as far as taking that casting and cutting away all the different sections of the part. So you see here we're adding some of those holes in now after we mill away that piece and make it nice and perfectly flat. And you'll see here that we go ahead and cut all those guys. They're going to revolve them and then mirror them across. And then boolean them away all at once there. Perfect. So you see this one, it's a simpler part as far as the workflow is simpler, but it's a novel workflow where you're able to come in and do this, what we call a hybrid workflow, where I create my buck of a part by auto surfacing it and editing the scan, and then come back and almost like virtually machine away all the pieces to cut away all these different pieces. There we go. This one's next over here. So cut, revolve, create all the bushings. Now, depending on what you're trying to do with this, you may not have to model all these. These are separate pieces, right? These are bushings that you purchase, rubber, grommets, and seals in some instances. But in this instance, we went ahead and modeled everything. So now we have this complete hybrid model. Take all that casting, auto surface it, add your features to it later, and then as usual, if you need to turn on the deviation accuracy analyzer and check how closely it follows, just to make sure that you followed it as you expected, and then turn that off. And just like before, if you want to auto surface this, live transfer this and send it over to CAD, you can go ahead and do so. So this is the second application, which is highlighting the ability to do hybrid modeling. Auto surface the main body, cut away, as I've talked about extensively through this one.